This video explains how to find the area of a trapezium. To find the perimeter, we could simply measure the distance around with a ruler, or we might have the measurements to think about finding the distance around. Again, to find the area, when we're relating to this trapezium in here, it is handy if we can relate it back to a rectangle. So you see what's happened with this trapezium in here is it has been rotated around and flipped, and now what it's made in this entire blue area is a four-sided shape. Might call it parallelogram or a rhombus. It is sort of a rectangle that's been squashed. So that can help us. Let's label some sides just of, again, with this first trapezium. Okay? You can see that there are some labels on this, but I'm going to forget those ones for now. We're going to call this top side A, because it is the top of the trapezium. This bottom length here, right across the bottom, we're going to call B, because it is the base. If we relate it to the other shape, you can see that B is up here with the flipped one, and A is down here with the flipped one. If they would have the height of the trapezium, then we're actually able to find the area of this entire shape and then halve it to find the area of the first trapezium. So what we would need to do is do A plus B. That will give us this length right across the top of the whole four-sided shape. If we then multiply that by the height, that will give us the area of this whole parallelogram. So let's multiply that by the height. A plus B times by the height. We only want, though, the area of this first trapezium. We know because we doubled the area at start, to get just this trapezium in here, we're going to need to halve it. So this right here is the formula to find the area of a trapezium. A plus B times by the height divided by 2, or half of A plus B times by the height. That's where A is the measurement along the top of the trapezium, and B is the base measurement along the bottom. Let's demonstrate using the formula in either of its forms. Using the trapezium, we can find that this is A, this is B, or the base, and here we have the height. So let's put it into the first formula. A plus B is 3 plus 9 times by the height of 9, all divided by 2. 3 plus 9 is 12, so 12 times 9, all divided by 2. 12 times 9 is 108, divided by 2. That gives us 54 square centimetres, remembering that area is a square unit of measurement. Again, we can plug it into this formula on this side as well. Half of A plus B, 3 plus 9, times by the height. So half of, you can use your multiplication symbol, because multiplication also means of, half of 12 times by the height of 9. So half of 12 times 9 is 108. You can see that half of 108 is going to give us 54 square centimetres. Let's now apply the formula to both of these equations. Again, choose the one that you prefer. I tend to think that setting it up like this is the easiest. So for the green one, A is equal to 4. B is equal to 10. So 4 plus 10 times by the height of 8, all divided by 2. That will give us 14 times 8. Remembering our order of operations, do the brackets first. Divided by 2, which will give us 112 divided by 2, because 8 times 10 is 40, 4 times 8 is 32, and I've added those together. 112 then divided by 2 is equal to 56 square centimetres. Now, finally, the yellow one, same formula. A is equal to 7, B is equal to 9 times by the height of 9, all divided by 2, gives us, order of operations, use the brackets first, 16 times 9 divided by 2. 16 times 9 is equal to 144. That's because I know 10 times by 9 is 90, and 6 times by 9 is 54, and I've added those together. So we've got 144 divided by 2 is equal to 72. So the area of this trapezium is 72 square centimetres.